So I've recently graduated at the University of Ghent in Belgium at the Faculty of Bioscience Engineering, and I received my master's degree as a bioengineer in chemistry and bioprocess technology. And I've worked approximately 1 year on today's subject. So I will start by giving a short introduction to life cycle assessment, followed by a short presentation on my thesis at the University of Ghent. To explain the concept of life cycle assessment as good as possible, I will tell you what life cycle assessment actually is, why we use it, and how we can apply it, how we can perform it. So first of all, life cycle assessment is a tool, a technique to assess and to calculate the environmental impact of a product during its entire life cycle. With a product, I mean a good such as a car, but also a service such as electricity. So for example, we could use life cycle assessment to calculate the environmental impact of the production of one car. How is the environment affected by producing one car? What are the emissions? What resources do we use, and so on. During this type of studies, it is very important to integrate all phases of a product's life cycle. In general, we can make a distinction between the production phase, the use phase, and the disposal phase. So this is the end of life of a product. Life cycle assessment is mainly used to compare the environmental impact of two types of products, two alternatives, to see which alternative is less damaging for the environment, so more environmentally friendly. For example, we could use life cycle assessment to calculate the environmental impact of two types of different cars. You could use life cycle assessment to calculate the potential environmental impact of producing one Zhiguli, an Armenian car, I think, compared to the environmental impact of a Mercedes-Benz. And for this, we could integrate the entire life cycle of the car. We could go from the raw material extraction to the use phase, also the manufacturing phase, to the reuse, the recycle, and the end of life of the product. And in each step of this entire chain, we will have to take into account the resources that we use during this process, but also the waste, the emissions that are produced during this process. So the emissions to the land, the air, and the water. We could use life cycle assessment to calculate, for example, the carbon dioxide emissions of these two cars. And this will allow us to decide which car is more environmentally friendly. So for example, Mercedes-Benz, the Class A cars of Mercedes-Benz have an alleged carbon dioxide emission of 160 to 180 grams of carbon dioxide per kilometer. And when we compare this to the Lada cars have a much higher emission rate, and due to emission rate regulation, we saw that the sale and the use of the Zhiguli cars were prohibited in America and also in Western Europe a long time ago. And this is, however, not the case in Armenia, because we've seen that there are many cars, many Zhigulis here still. It is also important, possible to quantitatively calculate the amount of resources we use to produce these cars, and also the types of resources that we use for the production or the use and of these two types of cars with a life cycle assessment. This will also allow us to find the environmental impact of these two cars and to decide which car is environmentally friendly if you look at the resources only. So there's a distinction between looking at resources but also looking at the emissions. Life cycle assessment is mainly used for to get a better understanding of the environmental impact of the product under study. The environmental issues that we focus on are environmental issues such as eutrophication, but also global warming and ozone depletion. So by applying life cycle assessment, we are able to get to know the environmental impact of the product, but also to find ways to reduce this pollution and also to reduce the use of the non-renewable resources by also incorporating environmental management in the company. It could improve sales and also the profitability of the company itself. And we also saw that the public image of a company can increase by using sustainable chemistry or by using life cycle assessment, because this shows that the company is striving for more sustainable development, which has beneficial solutions for everyone. Now, for the procedure of life cycle assessment, the procedure of this type of studies have been standardized by the international standards organizations, also called the ISO. Life cycle assessment consists of 4 main steps. First, you have the goal and scope definition, followed by the life cycle inventory and the impact assessment phase, and finally you have the interpretation phase. These steps aren't followed simply in this sequence because it's an iterative process, which means that, for example, the results of the final step, the interpretation step, can lead to changes in the first step, the goal and scope definition, and with the consequence that the life cycle study has to be changed, and this means you will have to start by the first step again. So it's quite complex to do it everything in once. To explain this procedure as good as possible, I will give an elaborate explanation starting with the goal and scope definition. So in the first step, we will define the goal and the scope of the life cycle study. And the goal, we will consider the reasons for carrying out the study, but also the applications of the results of the study will be considered. Furthermore, in the scope of the life cycle study, we will describe the system boundaries and also the functional unit. With the system boundaries, I mean the processes that we take into consideration. There are different levels we take into account. So first of all, you could have the gate-to-gate level, the cradle-to-gate level, and the cradle-to-grave level. I will explain them separately. When we, for example, consider or compare the environmental impact of 2 types of cars, we could look at the company that produces these cars. So we could look at the manufacturing company only, and this level is the gate-to-gate level, what comes into the gate of the company and what goes out of the gate of the company. So for example, if you have a car, if the parts of the car are imported from another country to the manufacturing company, this will be taken into account. So only the transport, for example, of those pieces, the company itself will incorporate all pieces and will make one car, and that's like the final output of this gate, of this level. But when we consider, for example, the raw material extraction, so making every piece of the car, when we consider those phases, then we talk about the cradle-to-gate level. So we go until the company gate, and by using the cradle-to-gate level, we will use more resources, but also more waste streams will be produced. This means that a more complicated calculation will have to be performed. But we will also have a better, more realistic view on the environmental impact of the car, for example. This level is often used in life cycle studies. I also use this for my thesis. Then you also have finally the cradle-to-grave level, in which the full life cycle of the car is taken into account. So we go from the raw material extraction to the refining and the producing phase, to the use, the reuse, the recycle, and the end of life of the product. So here again, you will have to take into account more resources and also more emissions, and this will decide the environmental impact of your product mainly. Now, for the functional unit, the functional unit is also very important in life cycle studies. It is mainly very important when you compare the environmental impact of 2 types of products. The functional unit describes and quantifies the properties of one product. So, for example, when we consider the 2 cars, the environmental impact of the two cars, we could look at the production of the cars only. So by using life cycle assessment, we are able to calculate the environmental impact of producing one Mercedes compared to the environmental impact of producing one Zhiguli. But we could also look at the environmental impact of driving 10 kilometers with the Mercedes compared to driving the same 10 kilometers but with a Zhiguli. And these two types of functional units will result in different environmental impacts, so different conclusions will be drawn. And it is very important for scientists, for example, to take this into account. So you should be very critical, know the system boundaries very well, because there again, if you use the other level of system boundary, you will receive another environmental impact, so different conclusions will be drawn. And it is very important to do this step very well and to understand everything very well, because this will decide your entire study.
If I could ask a question right here. It also impacts, correct me if I'm wrong, if you've thought about this, it also impacts depending on the quantities you produce, right? Because if you're producing 3 of these versus 200,000 of this telephone unit, there's a per unit cost, there's some fixed costs that you have, which then in your system definition you also have to assume some kind of a production level.
Yeah,
right?
Of course, but there are many variable costs that we have to take into account. But of course there are fixed costs and they don't change if you make, for example, 5 of these units or 20 units. So it's not something like you multiply with 10 if you use 10 times more, but it's,
In defining your system, you have to define the production quantities, right?
Yeah, how far do you go and how far do you go back? And the further you go back, the more complex the calculation will become, but the better your analysis will get, because you'll get a better view on environmental impact. Okay. For the second part, second step of the life cycle study, we will have to gather information regarding the input streams and the output streams of your entire process. So what are the resources and what are the emissions? And this data can be gathered from the company itself, so the source, but it is also impossible to gather information from literature or from a database. And this is we do this for standard processes such as the production of electricity or such as a wastewater treatment facility in a company. And a very well-known database is Equinvent. I think it's a Swiss company that allows you to use their software, but you have to pay for it. So it's quite expensive, but it's a good starting point, especially when there's a lack of data or when there's a lack of time or so. So what we do is for each flow across the system boundary, we have to characterize them by its mass, by its temperature, pressure, and composition. For example, when you have a wastewater stream, you have to characterize it by its mass, for example, 156 kilograms per hour, their temperature, pressure, and the composition. This data will be furthermore processed and modeled during this phase, and we will also perform a mass and energy balance to first of all control the acquired data, but also to complete the missing data. This phase is also the most time-consuming phase during the entire life cycle study. For example, for my thesis, I worked on this step only 6 months. And to illustrate you how complex this phase is, I will show you a flow sheet of the production process of my thesis. So what we did was we considered 3 levels: the process level, the plant level, and the cradle-to-gate level. And what we, as you can see, each flow is characterized by its mass, but also by its temperature, pressure, and a composition. These 3 things aren't described here, illustrated here, but we have them all in databases and so on. What we then further did was for each unit here described, we had to make a flow chart to understand the process very well and to define every streams. For example, we did this for the benzene sulfonyl chloride production, the compound under study, And we made a flowchart such as this. First, you had to understand the entire process very well, and then we had to find the mass, the composition, temperature, and pressure of each flow illustrated here. So I think this will illustrate you how difficult and how complex this step actually is. Then you have the third phase of the life cycle impact assessment.
But before you go on to the third phase, on the inventory phase,
yes,
there were some processes or products that are already
known quite well.
Are known, and the software captures the inventory of the goods and whatever inputs into the system. So it's only for the ones that you spent 6 months that there was no software databases, for example, or anything like
here
that.
I worked like 6 months to get everything, because working with a company, first of all, isn't that easy. They don't have everything in database, so they had to measure everything step by step. And the products, for example, I had to use were quite dangerous, so it was difficult to measure everything at the step I wanted. So, for example, I needed the composition of this step, but it was possible that they didn't have a sensor there, so they had to like put a sensor there to be able to measure everything. So that was the hardest part actually. But yeah, for the electricity production, we didn't have to do everything in detail because it wasn't needed. Okay. So for the third part, the life cycle impact assessment, we had to classify the inventoried flow, so the emissions and the resources, according to their contribution to different environmental impact categories. This phase exists of 3 steps. First, you have the selection of the environmental issues. So, for example, which environmental issue do you want to take into account? Is ozone depletion important for your study, yes or no? Or are the resources more important for you? Then you had the second stage, the classification stage, in which so different outputs and inputs were classified according to the environmental issues. And then the third phase was the characterization phase. The classification, so here we had to classify each input and output according to their environmental effect. For example, when you have a process that produces carbon dioxide, methane, and nitrous oxide, you should classify these 3 gases in the climate change indicator, because first of all, these gases are greenhouse gases, so they contribute to the global warming issue and are classified in the climate change impact category. Other often used environmental issues impacts are ozone depletion, acidification, eutrophication, but also resource-based indicators such as renewable resources or land use. For the characterization phase, the characterization is performed for each impact category, and this is done because different compounds have a different contribution to that impact category. So if we look at the climate change impact category, for example, we see that the environmental impact of methane is 23 times bigger than the environmental impact of carbon dioxide, and nitrous oxide has even a environmental impact of 310 times bigger than that of carbon dioxide. So it is very important to take these things into account, because 1 molecule of nitrous oxide has an effect that is equal to 310 molecules of carbon dioxide. So this will influence your environmental impact tremendously. Now, for the final step, the interpretation, we make an interpretation of the results obtained in the previous step, the impact assessment step, and we will try to identify the areas where improvement is needed, and we will try to draw conclusions according to the goal and the scope of the study. And when you use life cycle assessment to compare 2 types of 2 alternatives, we are able to decide which alternative is less damaging for the environment, so more sustainable. Now, finally, I think it is very important to mention that there is no such thing as the sustainable process, because a perfect process that doesn't emit waste or doesn't use resources doesn't exist. A life cycle study only allows us to decide, to conclude which process is more more environmentally friendly than another process. So it should be very realistic. There is no such thing as a perfect process. Now, for the second part of my thesis, of my presentation, I will give a short introduction to my thesis. I had to make a chemical compound, benzene sulfonyl chloride, in a mesoreactor, and I also had to perform an environmental sustainability assessment, a life cycle assessment study. First of all, what is benzene sulfonyl chloride? Benzene sulfonyl chloride is a chemical compound which exists of a benzene ring, a sulfonyl substituent, and a chlorine substituent. It is mainly used in the pharmaceutical industry for the synthesis of sulfonamides. This is a chemical compound used in antibiotics, but also for the treatment of hepatitis C. So it is very important in the drug industry. My thesis was in cooperation with the chemical company Proviron, a Belgian company, and it has facilities in Belgium and also in America. This company produces benzene sulfonyl chloride on a large scale, and they were actually the first ones who wanted to work with an alternative procedure to make benzene sulfonyl chloride. They wanted to know whether better results were obtained when you use mesoreactor technology, and with better results I mean like a better, higher efficiency or better, higher selectivity. They also wanted to know whether they would acquire a better market share in the market of benzene sulfonyl chloride, because they have quite a lot of competitors, especially Chinese companies, are very good in the production of benzene sulfonyl chloride. Also showing interest in green chemistry and green development would change their public image for the better, and because there is a big interest in cleaner ways to make different chemical products to reduce pollution, but also to reduce the use of non-renewable resources, also known as a concept of sustainable chemistry. So the goal of my thesis can be divided in two parts. First of all, I had to make benzene sulfonyl chloride in a mesoreactor. This was to verify whether a better, more efficient reaction was obtained, and whether a less side product was formed during the procedure. The second part of my thesis existed of performing a life cycle assessment study to do a comparison between the environmental impact of the commercial process compared to the environmental impact of the mesoreactor, the process in a mesoreactor. In the previous slide I talked about benzene sulfonyl chloride and its side product. I will try to explain the difference between these two types of compounds. So the starting material to make benzene sulfonyl chloride is benzene and chlorosulfonic acid, and benzene sulfonyl chloride is a blue compound here illustrated. What the company saw was that this reaction, the upper reaction, didn't occur for 100%. They saw that a side product was formed when you use benzene and chlorosulfonic acid, and the side product was diphenylsulfone, the red compound. And the goal of my thesis was to reduce the production of this compound by using an alternative process. And the process we performed was mesoreactor technology. This was the technology we used. And I will try to explain the difference between the technology the company uses, but also the technology I used at the lab. So companies in general use batch technology to make their products in large scale. They use a sequence of batch and vessel reactors to make and to purify their product. And these reactors are like 15 reactors in sequence, and each reactor can have a volume up to 1,500 liters. And this is quite big, and to illustrate this, here you see a picture of a company that produces polypropylene plastic, and as you can see it is quite big and not nice to see. The technology I use, the mesoreactor technology I use, is illustrated on the right, and the volumes we have is like maximum 5 milliliters, so the difference between 1,500 and 5 milliliters is quite big. And mesoreactors that are like small channels, incorporated in a tubing, and we use pumps to transfer the reagents into the reactor, and we use a T-piece to mix the two types of reagents. Working with mesoreactor technology can have many benefits. The main benefits are a better mass and heat transfer, a higher selectivity, and a better control of the reaction. And this is due to the small channels of the reactor itself. And this can lead to less side product formation, but also to a smaller reaction time, which is beneficial for each type of technology. Then you have another advantage, and this is like we are able to use more dangerous compounds, more hazardous compounds, because we work with smaller volumes. So if something goes wrong and there's a release of that compound in the environment, it's not a big problem because you only use like maximum 5 milliliters. So it's a high increase in safety at least. However, there are also disadvantages regarding mesoreactor technology. The main problem with mesoreactor technology is that we use small channels, so they have a small internal diameter, and so this leads to the fact that we're not able to use mesoreactor technology for solid chemicals because they are prone to clogging. Another important disadvantage is that we are limited by the construction material of the mesoreactor. So some acids are we were not able to use some acid because there is no mesoreactor in that material that is like consequent to the acid. The lab setup I used is illustrated here. First of all, this is a reaction we wanted to accomplish. So we used two pumps to transfer the benzene here and the chlorosulfonic acid and the mesoreactor here illustrated in detail. So it's a coiled channel tubing, and we use a T-piece to mix the benzene with the chlorosulfonic acid, and the reaction mixtures are captured in these flasks. Yeah, this is it. It's not very complex to work with it, but it's quite small, and it's yeah.
How do you reach scale with this? I mean, with the batch, it's huge, right? Yeah. I mean, with these levels,
scale up.
Right? How do you scale up this?
It's quite easy to do scale up because what they talk about is like about numbering up. So what they do is like use this type of tubing like in parallel. That's all we use, and we use like several pumps to do the same. I think it's quite difficult to understand because there are different types of microreactors, mesoreactors. You have also like mesoreactors that are like chips in which the channels are engraved in. So you have like a flat surface like very small, and the channels are engraved in the surface. And what they do is like just do it in parallel. They use many chips to make one product, and they can use like one pump, but also several pumps to do the same. And the main benefit here is you don't have to change the reaction conditions, and it's quite easy. The disadvantage is the pump. It's quite expensive pump. Like these pumps are like 2,000 euros for one pump. So if something goes wrong, if you have like clogging in your reactor and something goes wrong, it's quite a big problem. But it's very easy to do a scale up. Like when you do a batch technology, if you have to do a scale up, it takes several years to go from a lab setup to a semi large scale to a large scale. But here it is quite easy to do so. And there are companies who work with mesoreactor technology, like many pharmaceutical companies in Belgium. They make less of the product, but it's quite efficient. So. Now for the second part of my thesis, I had to perform a life cycle assessment. First of all, they wanted to know the environmental impact of the current process, the commercial process, and then we wanted to know whether it was possible to develop an optimized procedure to make benzene sulfonyl chloride in a mesoreactor, and then we wanted to calculate the environmental impact of this procedure compare the environmental impact of the commercial process with the environmental impact of the mesoreactive process, to know which process is like less damaging for the environment. Something I have to add at this point is that at the end of my thesis we saw that we weren't able to develop a fully optimized procedure. This was due to various practical but also chemical issues. So I was only able to make a life cycle assessment of the commercial process to know its environmental impact and also its bottlenecks. So this is no comparison, this is only like the environmental impact of the commercial process. The functional unit I used for this study was the energy content of the chemical compound, benzene sulfonyl chloride. So we wanted to know the environmental impact of producing 1 megajoule of benzene sulfonyl chloride. And for the system boundaries, we used 3 different types of levels. First, you had the process level, so what goes in the production process of benzene sulfonyl chloride and what goes out. Then you have the gate-to-gate level or the plant level. Some utilities were taken into account, so the things that we used in the plant itself. And then you have the cradle-to-gate level, where we consider the raw material extraction and other utilities. So I looked at these 3 phases. That's why I worked like 1 year on it. The second part of the study consists of the inventory analysis. So all the input and output data were gathered from the company, also measured by the company. This took like 6 months to find everything. However, there were like units we had to take from databases such as the electricity production, but also the wastewater treatment here, because it was quite difficult to allocate this process only. And so we had to characterize each flow by its mass, temperature, pressure, and composition. Then you have the third phase, in which we classify the input data and the output data according to their impact. We used 2 different types of methods to do so. Resource-related method was a SEAM method, also called the cumulative exergy extraction of the natural environment. This is a resource-based method, and here in this method we consider 8 different types of resources, so no emissions. The renewable resource, fossil fuels, nuclear energy, metal ores, minerals, water resources, land use, and atmospheric resources. To show you again how we calculate environmental impact, I will give you an example. So for example, we saw that during the production of benzene sulfonyl chloride, 2 kilograms of crude oil were used. We classified this compound in the fossil fuel impact category, and then we did a characterization by multiplying the mass of the crude oil to the characterization factor, and we got an impact of 92.4 megajoule for crude oil only. Then you had to repeat this for each type of fossil fuel, and then further for each type of resource. And after summation of all the different impacts of different resources and different compounds, we obtained an environmental impact of 3.4 megajoule of resources. This means that 3.4 megajoule of resources were used to make 1 megajoule of benzene sulfonyl chloride. So 3 times more resources were used to make it, which is quite a lot, I think. Then there is also the recipe method, which combines resource-related indicators such as fossil depletion with emission-related indicators such as human toxicity. So emissions and resources were taken into account. Here again, the input data and the output data were classified according to the environmental impact they have, and then characterized according to their contribution. Then the interpretation phase. This was after 9 months of hard work. first of all, the resource data. We saw that 65% of the total resources they used in the commercial process were fossil fuels, followed by 17% of water resources and 10% of nuclear energy. Fossil energy is fossil fuels are exhaustible resources, so very expensive, I would say. And the fact that we use a lot of fossil fuels and nuclear energy shows that this process isn't very, that the commercial process isn't very environmentally friendly, and this implies that the company itself should work further to find a more a cleaner way to make benzene sulfonyl chloride. Then for the emissions, we saw that the commercial process has the biggest impact on human toxicity and on climate change. These are also topics that are very important during the past couple of years. So the company should also work on the emissions to reduce these emissions by using cleaner ways to make their end product. Now a short conclusion, I think.
On this assessment phase, you looked at both existing practice and your new methodology, right?
I wasn't able to look at my new methodology because I wasn't able to develop a fully optimized process.
I see. So this is all analysis of the existing process. It's very fossil fuel intensive, and there is high levels of toxicity.
Yeah, that's all. If we would be able to have a fully developed procedure, it would be better. Then you could like see and compare the different types of indicators such as human toxicity. It is possible that the production of benzene sulfonyl chloride in this procedure in the commercial is better than the production in the mesoreactor technology, but I'm not able to say it now. This is like just one type of. It's not very good. It's not a very good type of study, but it's the only thing I could do. What is possible is like if you have chemical compounds that other companies produce also, and if they have like done a life cycle study, you could compare it with them, but that wasn't possible because it's quite a complex compound. And then finally, conclusion, life cycle assessment as a tool technique to assess the potential environmental impact of your product. It's an iterative process consisting of 4 phases. So first of all, you have the goal and scope definition, followed by an inventory analysis. So the input streams and output streams were all characterized by different parameters. And then you had the impact category, impact assessment phase, in which we classify all the input streams and output streams. And then you had the interpretation phase where different types of conclusions were drawn. Something I would like to mention is that as a scientist you have to be very careful and very critical. You should know the goal, the system boundaries, and the functional unit of your entire study very well to make good conclusions. Because, for example, many companies and organizations, they conclude what they want by using the right system boundaries or the right functional unit. So if you're like the scientist who sees the results, be very critical, like try to know everything they're doing, because the first step of your study is defining for your entire study. Thank you for your attention. That's it.
Questions?
No.
Yeah.
Yes.
So you said that the companies are doing life cycle assessment for ISOs.
No,
ISO standards. So, like, if I'm a company, I want to produce a kind of thing.
Yeah.
So, do I have to do a life cycle assessment or not?
No, it's not like...
I need to do that just for myself.
Yeah, you could do it for yourself. But there are like some regulations you have to keep into and
yeah, that's about ISO.
There are limits, like for example, carbon dioxide emissions, they will come and control, the government will come and control that, but yeah. That's
I'll
it.
look for that.
You're not obliged to do life cycle assessment.
So, for example, in your example, that Mercedes and Jiguli, so if they are doing comparison who needs to do that comparison? I mean, I want to understand in which level the
Well,
life cycle assessment is done.
the companies do it on their own. It's not something the government says you have to do it. They go, for example, to universities and they ask, do we have students who are able to do a life cycle study for me? But not many companies do that because, first of all, it's quite expensive to do so, and also many companies want to keep their information confidential. So, for example, my thesis was also confidential and I wasn't able to show everything because but it's not something you have to do. It's not something the regulation.
What's the benefit of company?
For the company, for example,
life cycle assessment.
First of all, for their own costs. For example, if they have a high emission on carbon dioxide, we could find the bottlenecks. Where do they lose a lot of energy and so on. For example, in this process, I also found something they had to change. And they were able to keep money, but also the public image improves because they will be able to say people, we are producing your product, but with less with a more environmentally friendly way. So like this.
You compared the BMW with the Zhiguli, right? Yeah. And you said that the Zhiguli is banned in America and Western Europe, correct?
It was prohibited in America.
Okay. But as far as I know, in Armenia, some take the filter out from the BMW, so basically...
Yeah.
That wasn't actually BMW, it was Mercedes.
I don't know, from those cars, and basically they do emit a lot of...
Yeah, of course, but I don't think it's you can compare it because the Zhiguli were old cars, so the technology back then was less advanced. I think there will be the Mercedes will have a better emission rate, but it's still not.
But the emission standards are being Armenia. You're supposed to take your car for emission testing. And that's a joke, you go pay some money, you get your certificate and you walk away without any testing. But in many countries, that's how they check. You take your car every 2 years to have emissions testing. And if the car emissions are higher in certain, for some compounds are higher than allowed, you're not allowed to drive the car.
In Belgium, for example, you have to do it every year.
Yeah.
And if it's higher than the limit, you have to or change your filter or whatever. Or you have to buy another car.
Do we have
which
that
happened
in Armenia? Do we have
Well,
that?
you get those. You take it for a check, emissions check, and you get this. Then you're allowed to buy insurance and blah blah blah.
You should look at the filters outside.
Yeah, but those checks are not. People actually aren't checking. You go there, you pay your money, you get that piece of paper, and that's done. It's finished.
Is that only in Armenia like that, or everywhere is?
I think
no. In the U.S., for instance, you actually go take it to certified centers, on many gas stations, and they test. They put the rod in there in the exhaust pipe. They test, and you fail, and it's automatically connected to the state computer. So it's automatically records. They've made it as difficult as possible to cheat the system. So.
There are also always ways to cheat the system.
But most it's too expensive to cheat anyway. It's kind of like most cars that people own comply. It's only very old cars that may not comply.
You mentioned the two methods of calculation. So it interests me if it is a kind of software where you put a data and it count that impact.
Yeah,
and
actually,
also
the third phase, I explained the 3 steps. So first selection and the classification and the characterization. These are quite complex steps to understand, but there's a software program that does this for you. For example, at the university I used CIMAPro, and it's software that our university made, and you just have to put in insert the input streams and the output streams, and they calculate for you the environmental impact. But it is very important to understand these principles because that's the only way to make good conclusions. If you don't know how you got the value of your climate change, then it doesn't matter that you know this value doesn't mean anything if you don't know where they got it from. But there are software programs and everyone uses them, so it's only a bit expensive to use the software. But
we have an educational version of it they gave us for free. This German company, P International. It's Gabi is the software. SEMA Pro and Gabi are the two big softwares in this field.
But as I understood, you need to collect all data before and to put in that software.
Yeah.
Maybe there are any databases or guides where you can take out that data, not to collect all data.
Yeah, for example, that's what I did. For example, for this process, for the electricity production, when you look at the cradle to gate level and you need like data for the electricity production, I did that. I went to a database, the EcoInvent database, and I took like the procedure, how much carbon dioxide is produced and so on, and I used that database for electricity production. But for example, for this process, I had to go and find every process, every unit in it. But there are unit standard procedures which you find in databases. There are just like good estimations, but not the perfect estimations. So the electricity production, if for example your company does electricity production on the site, then you have to then it's like smarter to do a study on their electricity production. But if there's like a lack of time, you should use the databases. But it's not possible to do this for everything because it's quite difficult to find a database which has data for this procedure, for example. It's not possible.
It's really hard to understand how to collect all that data for all life cycle.
I think there's a lot of processes and steps for which there already are databases people are using. It's when it comes to unique kind of processes that no one has looked at in the past. That's where the hard work starts. You know.
For example, for thermal oil heating, I was able to collect data from the company. So I received data, but for the step back, the natural gas production, I wasn't able to do that, so I had to go to a database. So it's like a step thing. The one thing you're able to calculate, but the other thing's not, so you have to go back and look at it in a database. And sometimes we didn't, we like looked and compared things. It's not perfect, but it's the only way to do a life cycle study.
One more question. And I think if it is more important to compare to different kind of products or maybe to compare with standards or with etalons, which is more important?
Depending on your goal of your study. So if it's like if the government says you have to do something you have to do a life cycle study to know the carbon dioxide emissions, then and to compare it with the limit or something, then it's better to do a study where you have like a value. But if for example, this company had a commercial process, and if I was able to fully develop the technology I used in the lab, then it is smart to compare these two processes. And then, for example, you could say that let's switch from the batch technology to the mesoreactor technology because there are many benefits. So it depends on your goal.
That first step of the process is very important, because that's where you define what is it you're looking at, what is it you're comparing to,
why are you doing
it that way versus the other way. So that first phase, it can't just be done very quickly. You need to think very carefully about how you define your problem, and that's where the issue you raise will be addressed. You know.
So I thought that you must have something etalon for you for the first step to have to know why you are doing that.
Well, that's the first step.
That's
what you
the goal.
discuss.
Why do you do that?
And you may decide there is no benchmark or etalon, as you say, and if there's no benchmark, it might take you 5 years to develop a benchmark, so you might as well compare it to something realistic.
You have to know why you're like doing this, because you will waste maybe 5 years when you're not, if it's not defined well, you will lose a lot of time. So you have to know why you're doing a life cycle study, because this takes time, a lot of time. I think if I had like maybe 1 year, I would be able to develop the procedure, but I will need like a half year more to do a life cycle study. So this takes time. It's not a easy
That's for
thing.
your PhD?
No, just if I would do a PhD, I could, yeah. but it takes a lot of time because I had to work on two things, so the chemical procedure, and then I had to go home at night to do the life cycle study, and it's quite complex and difficult because there are many things to take into consideration. So, but it's very interesting but hard.
Are there any sort of automatic data loggers that you have been using for your own data collection? Or
You mean the gathering of the data?
yes.
No. The company was quite, how shall I say, they didn't keep everything very well. They didn't have like a good database, so I had to go to them and I had to go like to 10 different people to gather information for one thing. It's quite difficult working with a company because not very, yeah.
If you need to produce the same amount of this matter, what would be comparison between sizes of mesoreactor and batch technologies?
The size doesn't change, so you use for example, if you use a mesoreactor of 5 milliliters, you will use like 10 mesoreactors of 5 milliliters to make the same amount. So what you have to do is like use a parallel form. This is called a numbering up.
That's clear, but physical size. Is there any difference between batch technology and?
You mean the reaction conditions, or
No.
The plant size?
Just plant size.
Yeah.
The reactor I used was something like this. I called it.
Yeah,
But
produced
1,500 liter batch production.
Yeah, produces.
If you scale up the mesoreaction, what size of a plant would you have?
I think something like this will be blocks like this.
That's the same. That would be the same as that huge factory you showed.
Yeah, because you use like a huge a reactor of like tubing like 1.5 meters, but you coil it up, so it's quite. It's like nothing. The volume is also very small, but there's like a high throughput, a high efficiency for some reactions, so it doesn't take a lot of place. So that's good.
So that big factory could be built into this small unit?
Yeah.
But then the biggest problem you have is clogging, right?
Yeah.
And that depends what
For
material
example,
you use the tube.
the side product that was formed during my reaction was a solid product. So I had to like clean the reactor many times because there was like a solid part in my reactor. And the syringes I used, so illustrated here, some of them were like 200 euros. And if there was like clogging and your pump was pushing, you would break it. And I done that like maybe 5 times, and it was quite expensive.
€1,000 damage.
And this acid, for example, is very dangerous. Once, like, one of the syringes broke and the acid fell all over the pump, which means buying new pumps, which means a lot of money losing. So these are like disadvantages, but if you have like a fully optimized process, then these things will happen less. But yeah, it wasn't easy to work with those things because they are first of all very small and difficult to use. But if you optimize it, it's something very good. You don't have to like control it also. In batch process, you have like many people who stand by the batch reactors to do like measurements and so on. And here you have like one reactor, and it's possible that you can make and purify your product in one step. While the batch technology, you have 5 reactors, for example, to make your product, and then you have like 10 steps to purify your product. And that's something huge you have to take into account, of course. But for some reactions, this is like the perfect solution, but for others, it's not good.
Now, mesoreactors are commercially used right now?
Yeah.
It's not just a laboratory?
No. There are companies, especially like pharmaceutical companies, so a bit more expensive, but they also produce it in small amounts, but the selectivity is better and the purity is also better. But there are many companies, Belgian companies like Janssens Pharmaceutica uses it, European companies use it, but not for large amounts. Not for making, I don't know, ethanol or something that is made like in huge amounts. But there are, for very expensive things, we use mesoreactor, microreactor technology. That's like even smaller, working with smaller diameters. So. but it's mainly used for very fast reactions. Other questions? Yes?
One more question. So, you said that comparing two products, you're comparing like in quantitative units or in functional units?
Where did I see it? I
Like
mean the
you
functional
compare-
unit or the...
yeah.
Be defining the, if
The
you go to the
units,
first step.
Yeah,
Yeah.
you're like
Well, it,
defining the units. Oh,
yeah.
that's not a question.
Yeah, the functional unit, it's like something that describes what you're looking for. For example, if you have the car, you want to know the environmental impact of producing one car, the production of that car. That's like a functional unit. It describes what you want to know. What is the environmental impact of producing
So
that
you
car?
said there can be different units. For you
Yeah.
have another example.
Yeah, I gave the other example was like driving 10 kilometers with that car. And these are like different units.
Okay. About one product.
Yeah, about one product.
Because driving would include the road and all the
Yeah,
infrastructure.
that's
you
like
need.
more the use phase than the production phase. You don't take into account how much resources were used for producing that one car.
Okay.
And the system boundaries define the how far you go in the chain of the product. So. Other questions?
Great. This was
Thank
very
you.
informative. Thank you very much.
Yeah,
And
thank
you're a
you
very,
very much.
very good presenter, by the way. Yes.
Maybe
Yeah.
I'm like calm. I don't know why. Maybe because these are Armenian people, but in Belgium, I'm like,
I think I didn't break my scissors. That's why you're calm.
yeah.
No, your anxiety was unfounded. So thank you very much.
You're welcome.